Hello, everyone, and welcome to the React Native Show podcast. And our topic for today is Open Native and how it allows native modules to be used cross ecosystems. And to discuss this, I have my guest with me today, Jamie Birch, who is a React NativeScript creator. So, hello, Jamie. Can you please add some more description to who you are on top of what I just said?
So I kind of came initially from the world of React Native and then got exposed to NativeScript, and along the way just ended up loving the idea of using native APIs from JavaScript. And so my mission nowadays is to find that perfect balance in between React Native and NativeScript. So I'm on the NativeScript technical steering committee, but always experimenting on both sides to see how we can make each of them better, for the sake of both sides.
So can you maybe explain two things for me? One, what is NativeScript besides like using native API using JavaScript? Like broadly in general, what can you do with it? And the second part of the question would be how it looked when you first encountered it several years ago, and how it evolved and what it is today.
So NativeScript, it's a few things. You can think of it as a framework or a library or an ecosystem, so it is a bit confusing. To me, what I like is the particular bit of it that lets you access native APIs. Unfortunately, that's a bit entangled with everything else, so let's just explain what you get. So today, typically, if you want to make an Android or iOS app in NativeScript, it's the end-to-end framework. It's just like you choose React Native or NativeScript. Once you're in NativeScript, you can call native APIs. So, for example, in Objective-C, you might do NSString alloc init to make yourself an NS string from the iOS SDKs. In NativeScript, you can do exactly that same function call from JavaScript. You can do NSString.alloc.init. And I thought that's just magical. Like, if I want to just get the battery level, I don't have to create a native module. I can just do it inline. I could even do it inside my render function because it's all synchronous. It's as if you were making an Objective-C app, but you chose to write it in JavaScript instead. However, it brings a bunch of other stuff as well. So what we're trying to get towards kind of have been in the last few years and continuing to do so is make it so you can use NativeScript anywhere. Just embed it into whatever framework you're using, and especially React Native. I've got my sights on. My hope is that NativeScript one day could be the last native module you ever write.
Okay, that sounds really interesting. So would you say that React Native is a dependency? Let me rephrase this. Would you say React Native is a dependency of NativeScript in order to get to that native part? Or is it the other way around? You envision it as a NativeScript being a dependency for React Native to get to that native layer?
You could actually do it either way around, and I've tried both and got different varying levels of success with each way around. Mm-hmm. So I've got a repository called React Native in NativeScript and another one called NativeScript in React Native.
Okay.
But the vision that I think would be the perfect developer experience is one that basically replaces JSI, replaces the bridge. And the idea would be you npm install NativeScript, and you can just, from there, immediately use all the powers of NativeScript, create a view controller, whatever, just in React Native without touching Xcode or anything. And it's increasingly looking like this could be possible through Node API. And for that, we do need to make Hermes support Node API. And, for people using JavaScript core still on React Native, we need to make JavaScript core support Node API. But there are implementations. And so all the jigsaw pieces are available. And at this point, it's just a political matter of pushing people to let us make those changes. And once it's all in place, we could have this.
So I guess we are coming to like the main topic of our conversation today, which is how to unify the native experience across the frameworks, across the platforms. So can you lay some ground rules for us, groundwork in how the systems in React Native, in Flutter, in Capacitor work right now? How do they work under the hood? And what is your next question? What is your vision of how to unify them?
So each of these cross-platform frameworks are all trying to do the same thing. They're targeting Android and iOS, and they're trying to create a common abstraction for calling various APIs. So we all want to use GPS, we all want to use accelerometer, etc. So why are each of these frameworks making native modules from the ground up, not looking at each other's work? And why can't we share work and work together? And the reason we can't is because each of these frameworks have chosen their own native module format, and they're not mutually compatible. React Native, for example, its native module format is, the classic format is a JSON bridge, where it posts a JSON message and it's got something to listen for that JSON message on the native side. What else have we got? Flutter, not too familiar. I think they use the word signals. I might be wrong. Capacitor involves a web view. So again, you have to post a message out to the boundary of the web view. You have something on the Objective-C side listening for that posted message. And yeah, it's very similar. It feels like Capacitor and React Native could share a bit of common DNA, but nobody managed to convince everyone to agree on a shared format. And so, as similar as certain bits may be, we're not at a point where in React Native you could just install a Flutter plugin or vice versa and use it, because they're not mutually compatible.
Yeah, so what you are saying is we have several different cross-platform frameworks like React Native, like Flutter. There are a few more. They all have their, let's say, proprietary system of dealing with native APIs. It is not easy. It is not easy to like switch from one to another. I think what you could do is like look inside the code and maybe get some like ideas of suggestions of how to do certain things, but those are not uniform, right? You cannot work with them. And for example, if you were to create a new cross-platform framework, you'd have to like do all of that groundwork all over again.
That is sort of where NativeScript is. We're a much smaller community than React Native. And so even though, there are times where we do want to use native modules, it's really nice to have that common abstraction for WebView or something. And, we just don't have the same number of developers around. And so it'd be really nice to reuse that work.
Yeah. What about the concept that we discussed previously, me and you, on different conversation, which is Expo Unimodules? Can you share some words about that?
So Unimodules, it was an attempt to create a unified API for all cross-platform frameworks to access native APIs from, I think, specifically from JavaScript, but maybe not even necessarily from JavaScript. I don't know the full story. But this was an initiative where there was conversation between representatives of each framework. I know NativeScript, React Native, at least were involved in it. I think possibly some others. But it's curious. It was a common standard, which was proposed by Expo and designed by Expo, and yet they were the ones left holding the bag. They were the only ones who made any modules with it. And it almost feels like they made extra work for themselves, because you've seen all they make a thin wrapper around every React Native module, and if you look at their SDK, or at least a few years back, they hadn't actually got around, I don't think, to writing unimodule wrappers for every single thing offered in the SDK. Maybe I'm wrong there, but either way, it was clearly a lot of extra work for them, and they were trying to push it. They did conference talks on it, and they even let's see what years. So from 2019, they actually made a proof of concept adapter for Flutter, so that Flutter would be able to use these unimodules. A year later, I made an adapter for NativeScript, so as of 2020, NativeScript could use Expo modules, but they sunset and deprecated rather the unimodules in 2021 in favor of Expo modules. And the reason for that, well, there's a few reasons. One is, by coupling closer to React Native, you can use more React Native specific features more smoothly. Things like JSI and whatnot. It's just a lot easier to map to. And for another reason, just nobody was adopting it, even when the adapters were written. And I think the reason for that is it was just putting more work on their plate. If you're a Flutter developer and you want to make a native module for Flutter, you're probably not thinking too much about the outside crowd. You just want to get the work done for your own purposes. And if someone comes along and says, hey, if you do all this extra boilerplate, you could have a native module for everyone else.
Yeah.
And think about it, as a React Native developer, do you know anyone who's started a brand new native module for React Native and thought, I'll do it as an Expo Unimodule?
No, but I can see some benefits to that. I can see some talking points around this, why you would want to do that. You get the community of Flutter and React Native coming together to make your native module greater. But at the same time, the React Native community, and probably Flutter community as well, they can take care of this. They can take care of their own modules, and they can make them great without the other parts participating. And then, so that's a plus, right? That's the carrot. But the stick is you have to also maintain the thin wrapper around it, and then you have to have shared issues on GitHub. Maybe in Flutter something works, but in React Native it doesn't, and other ways around. So I can see some benefits and some disadvantages, but probably the communities are so separate that they don't think in this unified way of writing native modules.
I think that's exactly the issue. These communities are very siloed. I don't know how conspiracy theorists to get about this, but I think sort of if you read too much Twitter, you'll see everyone works in tribes. Angular folks think about Angular things, React folks say React is the best, and React and Vue are always fighting. And React Native and Flutter never really cross into each other's territory. They talk within their own bubbles. And I think it's a huge shame. So really, a unified standard was maybe doomed from the start because nobody's interested enough in sharing and working together. So we needed a different approach in the first place. The idea of possibly sharing something, whether you like it or not. If you had a way to say, well, you wrote a React Native module, you thought it was just for React Native, but there is a tool to make it available for everyone.
I know where are you going with this. I think I know where are you going with this. So let me ask you the question, Jamie. What is Open Native?
Open Native, what a curveball. So Open Native was a project started by Amar Ahmed. You may know him from the React Native community, either for the Notesnook app, which is a Markdown editor. I think it's a secure note sharing thing. I don't know the details, sorry. But also for his JSI guide. So he's no stranger to looking around undocumented React Native internals and explaining it all for the rest of us. So he was the perfect person to spearhead this. And he came into the NativeScript community out of nowhere, and he basically said, well, again, I'm not quoting him. I'm
sure. Yeah.
He loved the architecture of NativeScript. He could see the potential, and he wanted to sort of fill in the gaps that it was missing. And he wanted, well, anyway, I'm not quoting him, but he's been great. And he had an idea to bring React Native modules to NativeScript. And so we talked a bit. I'd obviously had my original effort with Expo Unimodules, so I was very interested. And his idea was, well, hang on, if NativeScript, it can compile Objective-C, it can compile Java, it can look at all the same files as React Native. Why can't we just, use React Native modules ourselves? And so he set about building what you could think of as a polyfill for React Native core. And if you've ever used Webpack, it's sort of an alias for the React Native NPM package. So what we were aiming for is that NativeScript could just npm install React Native Web View or whatever you might think of, and then use it exactly as per documentation, have all the auto-linking taken care of using NativeScript command lines, lifecycle hooks, and just make it a seamless experience to give everyone full access to React Native ecosystem. And we thought, well, that would be really nice. But how do you do that? And so his idea was, well...
So sorry, just to summarize this part. So as opposed to Unimodules that had a wrapper around a React Native module that was like unified API for all other frameworks, this idea is the other way around. So you have your React Native module, and the NativeScript is responsible for reading it as is.
Exactly.
With no changes required.
And so the beauty of that is React Native developers can keep on just doing things their own way, not even worrying about the outside world. And we get freed of the maintenance burden of making all these native modules for ourselves. We can just use the existing ones. They're happy, we're happy. And that's why it can succeed where Unimodules didn't, because you don't need adoption. It's adopted whether you like it or not. How to do this, however, that's a big question. There's a few ways we could approach that question, but I was just thinking to myself today the best way to explain this, and I think starting from the JavaScript side makes sense. If you're a React Native user, you make a new app and you want to access a battery. Maybe you've installed a native module called React Native Battery, and it's a classic bridge style module, not a fancy new JSI one. In React Native, you'd write the following JavaScript. You'd write import native modules from React Native. Then you do native modules dot, I think we were doing a battery module, so native modules dot battery dot get current level. And it will be maybe promise format, so maybe you'd await that, and then hey presto, you got the battery level. That was easy on the JavaScript side, but there's a whole lot of stuff on the native side that made all that possible. And so for open native, we can do a sort of Webpack alias to say, okay, well, we're taking care of the React Native NPM package. We're going to make an object called native modules, and it's going to have something like battery. It's going to have all the native modules like battery registered into it. You've got that far, and then you think, okay, but where do we go from here? At this point, we need to know how things are set up in React Native core, on the native side. And native modules is a JavaScript object that proxies through. It's not actually a ES6 proxy, but in the term of the word, it proxies through, and effectively, under the hood, if you do native modules.battery.getCurrent level, it will call batchbridge.execute.js. Let me just check what it's called. Batchbridge.enqueue native call. And for each module, such as battery, and each method on that module, you'll have a different underlying call, batchbridge.enqueue native call, to that module ID, that method ID, and whatever arguments the user passed through. And then it will have a success callback and on failure callback.
Mm-hmm. And those methods, like in the native code, those methods are like either following the same naming convention or are like decorated the same way, so that React Native Engine knows that those are the methods that are like exposed to the bridge, to the like the executor.
Yes, effectively, there's this enqueue native call. It's sort of like if you've ever written a JSI module, they've injected a host object called batchbridge, which has the API enqueue native call on it, into the JavaScript runtime from the native side, and it's able to do native stuff when given JavaScript arguments. So it's a little complicated, but it's kind of like a JSI callback.
Mm-hmm.
So it takes in JavaScript arguments like string, number, null, and it turns those into Objective-C arguments, init string, init number, init null. And it's able to call a particular method on the module registry, on a module from a module registry. So now we learn another concept. There is a module registry. For every native module you make, it gets registered into that registry. So I think we know enough about how native modules are called, and we now need to zoom back out to the native side. Out of the React Native core library, and now look at some userland code.
Mm-hmm.
So if you make a native module for yourself, let's say it's an iOS native module, you'll always do the same things. You'll import React / RCT bridge or whatever it's called. So you get the bridge headers, and you'll create a class, and you'll decorate that class with a macro that says RCT export module. And that macro does something very clever, which is it adds a static method to the class. The static method's called load, and inside load, it calls RCT register bridge module. It's got a name similar to that. And what it does is it grabs a reference to itself, the class, and it registers it into the module registry. And you may ask sort of, well, who calls So if I made my class called battery or whatever, who calls battery.load in the first place? It's actually called by Objective-C runtime. It's got all Objective-C classes. If you put a static load method on them, they will get called as soon as the class is loaded into the process. Anyway, that is how modules automatically get registered into runtime. Into React Native's module registry. That's why you have all these macros. You could actually write it out manually. You really don't need the macros, and I think
it's a nice utility to have it simplified by React Native team, probably, right?
For sure. I think there's a balance between making things too mysterious and thinking what's actually going on here, and making things less verbose.
So the way you described it, probably 99% of our listeners or our viewers didn't get into this stuff that deep. What we do is we read what's on the React Native website, and if I want to make a native module, I just get the boilerplate from React Native website. It gives me the macros, it gives me the method name, and it tells me if you decorate your methods this way, you can use it on React Native side. That's all I need to know if I want to build that native module, if I want to use that. But if you want to take my native module and expose it into some other framework, some NativeScript, for example, then you'd have to know how it all works under the hood.
Yes, and it wasn't very, it made it really hard. In fact, a lot of the architectural decisions taken by React Native on how to do native modules are actually very hostile to this kind of project. For example, all the information we want, such as the method signatures, they're written in a .m file. We really want them in the header file. Mm-hmm. And the macros hide a bunch of things behind them. So your RCT export method, there's some useful information in that macro that, again, it's not in the header, so NativeScript can't see it. So, anyway, so we had to reverse engineer how React Native modules work. And that was basically a process of, okay, we've got this far. We know it involves a macro. We know it involves a module registry. And we know we're going to need this native modules object, which proxies through to call these methods. How do you then proceed from there? Basically, it was a process of following the headers. So looking at your my first native module, follow each header it pulls in, and try to build a web of, well, this header pulls in this other header from React Native Core, and you finally make a big spaghetti of every single thing that is needed to express a native module, and you say, right, now if we can make a CocoaPod that referenced all of those files, we'd be getting somewhere, wouldn't we? And that's exactly what we did. We looked at how React Native set up their CocoaPod, and we said, okay, well, we do need that, we don't need that, and went on, and then got to a point where we could say, okay, well, now if we just install this CocoaPod, we will have all this React Native bridge logic and native module logic available, and we just need to figure out how to call it. Mm-hmm. And the calling process, again, the clue was in native modules. You pull out the native module from the registry, you figure out what the name of the method is, and you pass the arguments through and you call it manually. So it's quite a lot of stuff to go over.
My question here would be, so I understand maybe 30% of what you just said. So let me add one additional question. Maybe I can understand it better. architecture of React Native, we have a concept of code generation, which is basically a build step to create some functions, to create some code on fly from like the templates, right? From the boilerplate that you made. So that's like build step code generation. On the other hand, you have like runtime code execution. So what is the balance? What is like the code gen that you are using while parsing the Objective-C files to like figure out the method names, figure out the macros? And what is the runtime step when you actually trying to execute the code?
There's a bit of both. So as I mentioned, there's a few hostile aspects. Now, NativeScript can see all native APIs that are for which there's a header, because at build time, NativeScript would use the Clang APIs. It follows all the headers, it figures out all the classes and methods and protocols, and it creates JavaScript equivalents for those. But its power does not reach React Native modules, because the really important stuff like the method signatures are hidden inside macros, and they're hidden in the .m files.
Mm-hmm.
So we had no choice but to use some build step logic where we parse the contents of the files. We could have used proper AST traversal, but the solutions for Objective-C are very slow, so we used just regex, and we found out the names of the modules, the names of methods, and the method signatures with just a lot of gross regex. And knowing all of that, we're able to build up a sort of JSON description of everything this native module does. And so we can say, well, this is everything you can expect, and now you just need an adapter. And this is on the, it could be NativeScript calls these, NativeScript using this JSON information calls the native modules, or it could be Flutter.
Mm-hmm. Yeah. So to summarize, in the build step, you use regex to go over the files. You get the information from the files because we have nicely named functions, RTC, blah, 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 right? You put all of that information to JSON, and you can reference that in runtime from whatever you like. And this is the piece that links us to Unimodules from Expo, right? Because they did basically that step, but by hand, right? By hand, they needed to create this thin layer. And you are creating this like with CodeGen, but only for React Native in this example.
Yes, there's definitely a lot of overlap. So I was actually able to reuse my experience in writing the adapter for Expo Unimodules for writing this adapter for React Native modules. All the same, you have all the same things to do. Say, how do we change a type from the NativeScript runtime, which would be JavaScript types, into Objective-C types? How do we grab where are these modules stored? How do we call them? And that's something NativeScript will have to do. That's something Flutter would have to do, capacitor, etc. So that's all largely build time stuff. I can talk about runtime stuff. I don't know sort of how we're doing on pacing though.
Let's jump into the runtime stuff for a little bit. Sure.
Okay. So runtime stuff is actually not all that much, I suppose. It's mostly just telling. So we mentioned that module registry. That's something that's being assembled in Objective-C land. And if you're going to consume the React Native modules, you are going to need to import the header for the file where that registry lives. And you're going to need to know how to reach into it and pull out the relevant modules. And you're going to have to make, when you're doing a sort of Webpack alias for React Native, you're going to have to make your equivalent of that native modules object. So in our case, we made a proxy. And the interesting thing we did there was we upgraded all classic style native modules to be turbo modules. That is to say, they're not loaded at startup, they're loaded on demand lazily.
Mm-hmm.
And another fun thing we did was instead of re-implementing the batched bridge concept, we just, instead of posting a JSON message, listening for the JSON message, and having this like really slow tennis match between the native and JS sides, NativeScript can call those things directly. So we just did, and we get close to
this
JSI
is such an interesting concept when meta team, like the whole React Native community, is in this like a transition phase from bridge to bridgeless, from old architecture to new architecture, from bridge to JSI. And what you just explained is that I can take my my first module that is written 4 years ago in like bridge fashion. I can reference it through NativeScript, and it will become like synchronous. Is that what you're saying?
Yes, absolutely. And in fact, we've got some performance numbers on the OpenNative repo that show that NativeScript calls React Native classic style modules many times faster. I think it might be 50 times faster. Let me.
This is awesome. I feel like this part of the NativeScript is not advertised very well, because like this might be very, very useful for some of the things that we do, right? For some of the libraries that don't have that much maintenance, don't have that much contributors, and we need them to like get through the bridge to the JSI. What we could do is actually like have them run in NativeScript fashion.
Well, I think my end goal for NativeScript is get to a point where that would be sensible.
Mm-hmm.
But the odd thing is, we've talked about when we were reverse engineering the bridge, we realized, hey, you could upgrade everything to native modules. Upgrade everything to turbo modules. Meta could do that today in React Native Core. They could make all classic modules upgraded to turbo modules. No problem. We've proved it. They just haven't.
Wrapping up the discussion about runtime, I will ask a last question. So throughout the conversation, we are referencing mostly methods and mostly functions, which are, I would suspect, much, much easier than dealing with views. So how about the view layer in all of this? Because my favorite libraries are not calculate this on native side. Those are rather display this on the native side.
Yes. So this was a phase 2 consideration. And so I should clarify, what I contributed to OpenNative was I helped a lot in the beginning with the iOS implementation of the sort of the classic stuff, and also with the command line stuff for auto-linking. I don't think we've really got enough time to go into that. But Amar's been the one who's, really taken on the majority, and he's continuing to implement views. And so that's actually under construction right now. But my understanding of how it works is effectively there's this class RCT view, and I think there may be some bridge module specific, some bridge view module or whatever. I'd have to remind myself. But either way, the fundamental bit is if you can implement your own equivalent of RCT view, maybe bring your own, the closest thing you have to Yoga, or maybe you can get Yoga working on your cross-platform framework. Whatever view is your primitive view, if you make something API compatible with RCT view, then there is definitely a path to get to React Native Web View. So you might have to sort of know up a lot of features, like, maybe we can't have rounded, maybe we don't implement border radius, but stuff like
shadows.
Stuff like, top position 0, left position 0, like that, you can implement if you know enough about how your internals work. And yes, the one big reason we weren't too interested in views is because you got to carry React around, because ultimately React Native Web View is exposed as a library of React components. Mm-hmm. So if you're using NativeScript Angular, like, how's that? Nobody's made an Angular to React translator that's really a household name. So the limit of what Open Native can give you is imperative APIs. So if you're happy with React Native Web View, where you can just call .inject JavaScript or .execute JavaScript, evaluate JavaScript, whatever name they've chosen, and then you remake that component for Angular or whatever, then, that's very possible. But even better, maybe you're using React NativeScript and there's probably a way to hook it all up and you get everything for free.
Okay. It seems like I said, like the views are much, much harder, and like the methods and functions are ready and available to use. So thank you for that. We will move on now to take a broader look, take a step back and look at the Open Native in its entirety. So what would you say is the piece that we just discussed, using React Native modules in NativeScript? What is the Open Native in general in reference to this? What are the plans and other working pieces in the whole ecosystem?
So Open Native, we chose quite a broad name for the project in the hopes that maybe one day it'll become something bigger. We got quite a few GitHub stars, and I'm not sure. Anyway, we got a bit of attention on Twitter, and I was really hoping that ball would start rolling and people from other communities would appear, sort of Flutter and Capacitor, and say, hey, that's exactly something we need. Let's help you. But that never happens in open source. So here we are. It's just, well, I say we, it's mostly Amar, but it's entirely Amar at this point. If the other communities had come out and said, yes, we will lend you our expertise, we would now be in a position where every cross-platform framework could use each other's native modules, because we'd all build the adapters, we'd all build the logic for parsing native modules and that sort of thing. But ultimately, it is what it is, and it is where it is. So I'm thinking ahead to a future and thinking, is there another way we could get cross-platform, cross-ecosystem collaboration? And I'm happy to say there have been some movements on that.
Oh, okay. So something different than Open Native.
Exactly. So I overheard from Vladimir, who works on the React Native Windows. I'll need to check his surname, but it's Vladimir. And he is a member of the Node API team. So he is a very interesting bridge between these two worlds of React Native and Node. And he works on, low-level stuff, C++, cross-language stuff. And he's been pushing to reimagine JSI as something that's built upon... There's a few things to discuss here, but the main things he's pushing at the moment is trying to get Hermes to implement JSI on top of something ABI stable. The end goal of that is that we could ship pre-compiled native modules, which for things like Firebase would save you a lot of time.
Yeah.
So, and a necessity for that is you need JSI, which is based on C++, to be ABI stable. And C++ doesn't have a stable ABI. But what you could do is implement JSI on top of something that is ABI stable, which is Node API. And the cool thing about this is, okay, if we bring Node API to Hermes and we make Hermes as JSI based on Node API, which is something that will be made possible thanks to that, now we've got Node API in Hermes and we can do all sorts of things. Any NPM package that makes its own native add-on using Node API can then simply be NPM installed and used as is in React Native. And it gets better from there.
Yeah, so, I hope you have some links and references to this digression at the end of the episode, and we're gonna link this in the show notes. You said you overheard it somewhere, so I hope you overheard it on Twitter or like blog post or something like that, so that we can link this somewhere, because this is really interesting. And like I forgot to recap the like Open Native versus like React Native implementation of Open Native concept. And I think it's time. I think it's time to like conclude the episode. So let me rephrase what you said like just 3 minutes ago. Open Native is and please like interrupt me if I'm saying something stupid and you want to correct me. Open Native is a project that aims to have intercompatibility between cross-platform frameworks so that they can each other use their native modules interchangeably. If I'm a React Native user, I could have an adapter and some code gen mechanism provided by NativeScript that reads Flutter native module and allows me to use that Flutter native module in my React Native application. Right now, this is not...
you there. I think so. I'd not thought of using NativeScript as the glue between the two. But I think what we do is we'd leave that to Open Native. But it's an interesting point. It might actually be possible to let NativeScript take care of that.
This is just how I understood the concept, but it doesn't work like that right now. Right now, what you could do is to call React Native specific modules from NativeScript. That's what's available, and that's what we've discussed in this episode. Okay. Yeah, I think we have it. Thank you so much. It was such an interesting discussion. I rarely have opportunity to listen, maybe not even discuss, because I'm not on the level of discussing macros in Objective-C, but like listen to you explain how to reverse engineer like real core of React Native. And then because of those reverse engineered things that you learn, like put something on top of this and like make something else. Like this is such an interesting concept and very, like for me as a developer, interesting. So thank you, Jamie. It's just really, really good to have you here. Thank you, all of you who listened to this episode. I hope you enjoyed this as well. And check out more episodes of the React Native Show podcast and subscribe to our newsletter.